So far we have looked at writing a polynomial in factored form by factoring out the greatest common factor. And we've also looked at writing a quadratic trinomial in factored form by factoring it into two linear binomials. So in Algebra 1, when you're asked to fully factor, what you're going to do is combine both of those two strategies, and sometimes you'll just need to do one or the other. So first you're going to try to factor out a GCF. If there's not one, then you go to step 2. If you have a quadratic trinomial, you'll factor that as two binomials. And then you will rewrite the final factored form as the GCF times those two linear binomials. So let's look at some examples. In this first example, we do have a clear GCF. That was supposed to go underneath it, of x. So if we divide it through by x, we have x squared plus 2x. Now I can't see it. Minus 8x. So x squared plus 2x minus 8. So factoring out the GCF, we have x times x squared plus 2x minus 8. Now we're going on to step 2, noticing that what's inside the parentheses is a quadratic trinomial, so I can factor that into the product of two linear binomials. So the two numbers that multiply to -8 but add to 2 are 4 and -2. That means x squared plus 2x minus 8 can be factored into x plus 4 times x minus 2. And then my final factored form, I need to include that GCF. So my final factored form is the GCF times the two linear binomials. To check this, I don't really have space here, but I just want to make sure you know how to check it. There's there's two different methods. I could multiply the two linear binomials first, or I can multiply the GCF by the first binomial. So I have x squared plus 4x. And then I multiply that by the second binomial. So I have x to the third minus 2x squared plus 4x squared minus 8x. And then I hope that equals my original polynomial, which it does. So this is the fully factored case where I do all of the steps. I factor out a GCF, I factor the quadratic trinomial into the product of binomials, and then I write my final expression as GCF and two linear binomials. This case, I'm only going to need to do step 1. So sometimes when I say fully factor, you're going to factor out the GCF, and then you're going to realize that inside the parentheses, you do not have a quadratic trinomial. So you are done. When you factor out a GCF and what's inside is not quadratic and not a quadratic trinomial, you are done. Let's try this case. Factor out 6, the GCF of 6. And it may appear that I'm done, but I'm not. X squared minus 4 is one of those honorary linear or quadratic trinomials where I multiply to -4 but add to 0. So 2 and -2. The fully factored form of 6x squared minus 24 is 6 times x plus 2 times x minus 2. Most common mistake is to forget to write that 6 in your final answer. So the GCF needs to be in front of your final answer. Here's another case where I will do all 3 steps. So factor out the GCF, and I get 2 times x squared plus 2x plus 1. The GCF is 2. And then I have a quadratic trinomial. What are the two numbers that multiply to 1 but add to 2? Perfect square, just 1 and 1. 1 times 1 is 1. 1 plus 1 is 2. This one is included because the fully factored, fully simplified case would not be 2 times x plus 1 times x plus 1. It would be 2 times x plus 1 squared. When you're going through these examples, the most common mistake students make is they kind of freak out in the case where there's just a GCF. They forget that that is writing it in factored form when it's mixed in with all these other cases. So we're just going to factor out a GCF here. Nope. Just going to factor out a GCF of 2x. And then we're done. So this is the factored form. It's just like if I said write it in factored form by factoring out the GCF.